let's try this question. And, they're starting to get pretty familiar here because here's a graph type question, but we're supposed to find out where f equals g. It's a bit of work, 6 marks. So the first thing we must do is go sine x equals cos 2x minus 1. Now, why did Mr. Autry have 3 things to choose from, but he chose 1 minus 2 sine squared? Well, one of the reasons it's good is this 1 minus 1 is 0. The other reason that's good, now it's just all sine. So we add 2 sine squared x, we factor out sine x, and now it's in the perfect form. And we made 0 on the right-hand side to get the general solution. Sine x equals 0, or sine x equals minus a half. Now, there are 2 different answers. There's negative 30 degrees, or there's 210 degrees, 180 minus 30. Those are the 2 general solutions. There's other ways you can express this, but those are 2 the right answer here. K is an element of the integers. Where does sine x equals 0? At 180 degrees or any multiple of 180 degrees, that's when sine x equals 0. Those are the places where they're going to cross each other, where they equal each other. Now we're going to sketch the graph. And Mr. Autry's done it. He sketched the graph there. And he's got the graph first of f. F equals sine x. F equals sine x here. And so he graphs f equals sine x. And I think it might be a little typo there. I just saw there's a sign that all of a sudden it's 2 sine x. It should just be sine x like that. And how do you know the graph of sine? Every 90 degrees, and it says between minus 90 and 270. So it's minus 90, 0, 90, and then 180. It goes up to 1. You just have to know the graph of sine. That's an easy one. Put 90 in 1. 270 and minus 1 is an endpoint, and minus 90 and minus 1 is the other endpoint. So the sine one's easy. But the cos 2x minus 1, that one there, how are we going to graph that? Well, it's got a period of 360 divided by 2, 180 degrees to go through a complete wave. And the step is every 45 degrees happens. And the graph has shifted down 1. Now, it would normally go through 1, but it's shifted down 1. So it's going to cross right there at 0. Then 45 degrees, it moves 1 right to there. That'll make it minus 1. Another 45 degrees, 90. It'll get all the way down to minus 2. So then it makes this kind of cosine or sine wave, but it just keeps going. Another 45 degrees, back to the middle. 180 degrees, back to 0. And I don't need a calculator to do this and get the answers and just copy it down. I know that 225 degrees, it must be minus 1. And 270 degrees, it's minus 2. If you put that into your calculator, at 270, the cosine of 2 times 270 minus 1, it'll equal minus 2. And then it follows the same pattern, falls back down to minus 1 here, and at the end, it's minus 90 and minus 2. So there's your cosine wave, cosine 2x minus 1. And now I'm looking at the places where they cross. Minus 30, 0, 180, and 210. It even looks about right. There it is, minus 30, 0, 180, and 210. Now, for which values between here is f, this function f, below g? Well, let's just take a look here. Let's just see the places where it's below. Well, there's 2 places. See this little section here? It dips below, in between 0 and minus 130. X is less than or equal to 0, but it also dips below in this little section when x is less than 210, but greater than 180. That's when f goes below g. And we have the answers here that we got. It's these values here that are key to finding these regions. That's a little tricky for some people, but that's how you do it. Okay.